Hello everyone. We had asked you in a bonus question that when we are doing spherical coordinates, and again we are defining spherical coordinates with engineering ISO standards, why do we go theta 0 to pi and phi 0 to 2 pi? And think about it, effectively what we are doing is with a radius line, we are making a line which goes up. With theta going from 0 to 2 pi, we make this disk. And then we take this disk and we rotate it around the z-axis, and in doing that we make the sphere. So that's one choice, and this is the choice we use to in the spherical coordinate system. Now we could have another choice that instead of making a half disk or this half Chinese paper fan, we could have also made a circle or a disk with theta. So theta goes from 0 all the way back to 2 pi. And in doing that, I take this and I rotate phi. And when I rotate phi, now I only have to rotate it 0 to pi. So I start, let's call this theta 0, phi 0. I start from phi is equal to 0 and I rotate it till this comes on that side. As I'm doing this, this part is writing this part of the sphere, the back part is writing the back part of the sphere. So physically we should be able to do that too. What is the issue? Now you have been sending me solutions, and many of you in the solutions have said, well, dV is r square sine theta dr d theta d phi, or the surface element is r square sine theta d theta d phi. You have said, if I chose these to be the arguments, then when I integrate, basically I would get r square dr sine theta d theta d phi, and when I integrate this, theta is equal to 0 to 2 pi, either in this element or in this element, I get volume is equal to 0 and surface area is equal to 0. That's what you have said as your solution. Yes, absolutely you're going to get volume is equal to 0 and surface area equal to 0 if you use this element and have theta 0 to 2 pi. But all that is telling you is that this differential element is not correct if I want to go over that range. That's all it is telling you. You are taking a look at a symptom and considering it to be the cause. Right? This is the symptom of the fact that this differential element does not represent dV element when I want to use these limits. Theta is equal to 0 to 2 pi, phi is equal to 0 to pi. There is a difference between knowing something and understanding it. Throughout your university career, you are going to be filled with lots of facts. If you only know those facts and don't understand them, they are going to be lost very, very soon. It's going to be garbage in, garbage out kind of a scenario. And that's why, if you really want to develop a deep learning and a deep understanding such that you can take this 20 years from now and it comes back to you very, very quickly, you need to figure a way out to understand what the hell you are doing, not just apply terms like this. So let's take a look and try to understand what these various terms are. Why is this going to 0? Mathematically, obviously, this is going to 0 because sine theta, if we take a look at sine theta term, which goes from 0 to 2 pi, I have equal negative amplitude equal positive amplitude. I didn't even need to set up the integral. I would have told you the answer is going to be 0 because you have a function which is anti-symmetric. But that is a symptom, not the cause. So we had said, how did we define spherical coordinate system? Let's say we have x, y, and z. We had said, I want to make this sphere by rotating lines around, right? I want to make a sphere by taking a line which is centered at the origin and somehow rotate this around the sphere, and as I rotate it, it should be able to go to different points of the sphere and be able to write it. So instead, we are taking a line which has the radius r, and this line, with this line I can go to different points on the sphere. So by taking the line, I can go to a point here, or I can go to a point here, and I can go to the point here. I should be able to move this line. Each of them has a radius r, and I should be able to move it in angles such that I get to different points on my sphere. Then we had said, let's see how are we going to do. One option for us is we have theta, which is what this line OP makes, what angle does this line OP make with the z axis. So think of this line. Right now it is parallel to the z axis. Theta is equal to 0. Then I can change the angle of the line, and in changing the angle of the line, I can go to anywhere on that half semicircle. That's what theta is allowing me to do. So again, with respect to the sphere, if I change r and theta, what we are able to do is go anywhere on this plane like that. Right? So anywhere on the plane like that. So that is one thing we do. We are able to change the angle with respect to the z-axis. Now what we want to do, so this is one thing we can do. The other thing we have to do is move this in this plane so that we start making circles like that. And all the circles which I make, these circles are being made in the horizontal plane. The horizontal xy plane, I am making circles in that region. So with respect to that, I have a circle being made which is like that, and if I look at this circle from the top, if I watch the circle from the top, then that circle to me is sitting in xy plane at some z is equal to r cos theta. It's sitting in that xy plane at a slightly higher z, and that circle makes a radius of P1P. So this is the radius which I have on the circle which is being made over there. Again, this is a right angled triangle. So P1P is simply r sine theta. Right? This is what P1P is. And what does this represent? This represents the radius of the circle you're making at theta is equal to theta. You have gone and you have took this line and you have tilted it around till you have gone to some angle theta. What is the radius of that circle you're going to make in this horizontal plane? That is what is represented by r sine theta. This is a physical dimension. This has to be positive. So r sine theta is a physical dimension. This has to be always positive. It can have a negative r sine theta has no physical meaning, right? So if r sine theta has to be always positive, and the question was asking what would happen if I make theta go from 0 to 2 pi. Well, sine theta goes like that. Sine theta goes from 0 to pi to 2 pi. Right? That's what sine theta looks like. Sine theta is becoming negative from pi to 2 pi, and if I want to use this limit, this is a physical distance has to be always positive. I will have to change that function not to r sine theta but to r modulus of sine theta, such that the function always remains positive when I take the modulus of this function. I'll have to use r modulus of sine theta when I go theta is equal to 0 to 2 pi. I've just added complexity. If I restrict myself from theta 0 to pi, function is always positive, and I do have an opportunity to make a full sphere by making phi go from 0 to 2 pi. So that keeps it very simple. Whereas if I wanted to go to our second choice, that theta goes from 0 to 2 pi and phi goes from 0 to pi, then I have to account for a modulus in the function. Everywhere we have put r sine theta, that has to be replaced by r modulus sine theta. And I've just added complexity from mathematical point of view. And another principle of engineering is keep it simple. Theta 0 to pi, phi 0 to 2 pi keeps sine theta always positive within my limits, and in doing that I don't have to account for the physical nature at all. That's the reason. That's the physical reasoning behind what we are doing.